For division, you follow the same rules. So when you're dividing, as long as you have that same base, you just subtract your exponents. So again, because we're working with fractions, if we look at number 4, we're working with fifths. This is 10 to the 2 fifths. So this is really 10 to the first. We just don't write the power of 1 there. So if we want to be working with fifths, instead of 1, just make it 5 fifths. Then you can work with it a little bit. So we've got 10 to the 5 fifths over 10 to the 2 fifths. So if you subtract them, we get 10 to the 3 fifths. Again, we can't have exponents that are negative or fractions, so we're just going to rewrite this as the 5th root of 10 cubed. So if we look at number 5, 56 to the 1/4 over 7 to the 1/4, they are not the same base, but we can distribute the power inside there if we want to. So again, if you want to put it over 1. So this is going to become 56 to the 5/4 over 7 to the 5/4. So, are the bases the same? No. But is the root or the index and the power the same? Yes. If we rewrote this fraction in radical form, 4 would be the index for the entire thing, since they both have a denominator 4 for their exponent, and it would be to the 5th power. So we could do 56 over 7 to the 5th power. Well, you can divide 56 by 7, correct? 56 divided by 7 is 8. So this ends up being 4th root of 8 to the 5th. And we could figure out what 8 to the 5th power was, but if your index is smaller than your power on the inside, then you have an entire or perfect 4th root of 8 in there. This is really 5 8s being multiplied together inside there. So that 1/4 root leaves you with just 1 left underneath, if that makes sense. And then leaves you with the 4th root of 8 by itself. So when your index is smaller than your power, you can pull an entire root out from underneath that radical. So just keep that in mind. For number 7, it says the ratio of the magnitudes of 2 earthquakes, magnitude 1 and magnitude 2, is given by the equation below. So the table gives the magnitudes of some of the largest earthquakes that have occurred in the U.S. How many times stronger was the 64 quake in Alaska than the 1812 quake in Missouri? So it gives you your little equation over here on the side. So we're trying to figure out the magnitude of these earthquakes in scientific notation. So it literally just says 10 to the magnitude 1. So the magnitude of the first one, the larger one, was the one in Alaska. So if its magnitude was 9.2, we're just going to say, okay, 10 to that magnitude. 10 is part of your equation. We're just writing in the magnitudes of what we were given. And then the magnitude of the second one it's talking about is the Missouri one. So 10 to the power of 7.9. So since they both had that base of 10, we're just going to subtract those powers and get 10 to the 0.9 power, or 9/10 power. And if we really want to value, 10 to the 0.9, or 9/10 power is about 7.94. So we're going to say about 8 times stronger. The Alaska one was versus the one in Missouri. So moving along, we're just going to do a couple more division ones here. So if you look at number 9, 4th root of 80 over 4th root of 5. Again, remembering that if it's helpful, if they have that same root or index like above, we put them together. This one, it benefits us to do the same thing. If we put them under one root and just do 80 over 5, that becomes the 4th root of 16. And that's a perfect 4th root because the 4th root of 16 is just 2. So sometimes you kind of have to evaluate what you're working on and figure out what's the best option or method to use. So if we look at 18, we don't have a number base, we have variables, but it's the same idea. Like we were talking about that group of 5/8 to the 4th root. This is 6 r's being multiplied together. We don't write it out as that, we write it as r to the 6th, but that's what it is. So how many times does 6 go in to 6? Because that's the number of perfect 6th roots you would have then. Since it's just 1, r to the 1st. How many times does 6 go into 18? 3. So because they go in perfectly, there's nothing left to have underneath that 6th root. So we are done with this one. And number 19. Just another division problem. So let's do our numbers first. We just can reduce or divide those. So 56 over 7 is 8. And then we've got our a's, which are in 6. So instead of a to the 1st, I'm going to, which is really what that is, I'm going to make that a to the 6. So 6 minus 5 gives us a to the 1/6. There's no or nothing to combine with our b, so we're just going to keep that b to the 3/4. And our c guy is negative, so it actually needs to come up to the top with everything else. So the 8c cubed I'm going to put out front for right now. And now technically, the proper way to do this would be to make these like denominators and put them under the same radical, but there's nothing wrong with having them in 2 separate radicals. So I would be okay if you guys wrote this as the 6th root of a to the 1st times the 4th root of b cubed. But if you did choose to make them both 12ths with a like denominator, it would be the 12th root of a squared, and 3/4 would be 9/12. So b to the 9th. So I would really accept them both. So again, just paying attention to those properties um, that you would normally use with exponents. It's just now some of them are fractions.